Hello, and welcome to Performance Testing and Service Virtualization, the one-two punch for applications that rock. My name is Bernard Shimshak. I'll be moderating today's webinar. I'm currently the co-leader for the Ohio chapter for Vivid and a co-leader for the TQA Special Interest Group for Vivid. Been a member for about 8 years, and I was asked to volunteer for this today. And I think this is a great opportunity to learn about server virtualization and how that can help us with our performance testing. So while we wait for, go ahead and proceed to the next slide here. And while we wait for everyone to log on, I'd like to make a few announcements. If you want to take us to slide number 2, please. Thank you. The HP Discover Conference is coming up in Las Vegas on June 11th through the 13th. Thousands of IT executives, managers, architects, engineers, and solution experts from around the world will be there, exploring technology developments, strategies, and best practices. There will be hundreds of business and technical sessions. To get the best conference registration rates, use the code VIVID. This will save you $300, and it is a better rate than the current early bird pricing. Plus, 5 registrants who use code VIVID to register will be entering into a drawing to win a free pass to HP Discover 2014. All right, go ahead and take me to slide 3, please. Vivid is hosting advanced pre-conference training at HP Discover. This is a great opportunity to deep dive and develop professionally. There are 10 courses to choose from, but the courses most relevant for this group based on today's webinar topics are the deep dive into unified functional testing, deep dive into ALM 11.5, HP ALM best practice templates and intelligent reporting, mobile functional testing with UFT Mobile, mobile performance testing. All right, so the cost of this training course is only $99 thanks to our sponsors. A Vivid training course can be added to your new or existing HP Discover registration account. Just complete the information, and course descriptions can be found on your HP Discover registration account. Okay, go ahead and take me to the next slide, please. All right, I think most have had a chance to log in. So let's just get started with today's event. Is brought to you by HP and is a part of the Performance Testing 101 webinar series focused on performance testing, performance engineering, and performance lifecycle. The next event is on April 17th and is titled Performance Testing Beyond Basics, Exploring Advanced Scripting Techniques. You can register at the URL shown and that we will send to you now via chat. Okay, so today's speakers are Dr. Farhan Kilikow and Marek Novotny. And we also have 2 prize drawings for a $100 American Express gift card. The first drawing will be from everyone who entered into the drawing during registration. The second drawing will be from everyone who is online on the line now. Those drawings will take place after today's webinar. The winners will be notified by email. So watch your inbox, and thank you for joining us. The Q&A will take place at the end of the presentation during the last 15 minutes. Please type your questions into the questions pane as we go along, and we will address them at the end. Today's session is being recorded. The recording, along with the answers to your questions, will be posted. Both should be available in about 5 days, and we'll send you an email once they are available. All right, so for now, I'm going to go ahead and hand it over to Farhan.
Good morning. Today we'll be talking about composite applications, performance testing, and the problems we have in test environment where HP has a solution, HP Service Virtualization. Today's increasingly competitive and impatient world, success in delivering software of value depends on speed. However, with great speed comes great responsibility. Being first and fastest does not mean we have the best quality. Application teams must move quickly, but must also provide functional quality, performance, and application security levels aligned with demanding compliance and business expectations. HP Software provides the HP Service Virtualization solution to development and QA organizations, allowing them to eliminate dependencies in composite application development and testing by virtualizing those services. Applications are going through a dramatic change. For example, banks, e-commerce portals, or even news providers now offer access to their functionality through smartphones and tablets. Let me show you what I mean by composite applications, and we'll share with you what we see in the screen. In the simple purchasing business process, we see 6 different integrations, at least 13 different systems, and many more.
I'm sorry to interrupt. We did launch the first poll. If you wouldn't mind if we read the results from the first poll?
Sure.
Okay, so the first poll was how much do you know about service virtualization? And it looks like most have voted here. So I'm going to close the poll, share the results, and Bernard, would you like to let Ferran know what the results are for the first poll?
Yes, I'm very excited actually.
Absolutely. Our first poll is in, and it looks like the question was, how much do you know about service virtualization? And we have about 61%, so almost 2/3 of the audience just heard about it and wants to learn how that helps. About 30% have some knowledge and have tried it already. Nobody seems to be at the expert level, and about 13% are just hearing about it today.
Great. Thank you. Well, as we were talking about, this application that you see on your screen is a typical composite application. To be able to complete full transaction, credit check is done, calling out to an external credit check service or tracking service. What if the application team made a change to the application, such as adding an additional product line or supporting customers in other geographies? How can the change be tested for functionality and performance? Running the test would include the call out to the third-party credit check service, and the third party will charge the company a fee each time their service is accessed. These additional costs are often too high. Let me move to the next slide where it sounds very familiar. I'm sure you hear about all of these. Keeping track of development, schedules, especially when we have multiple vendors and dependencies in composite applications, naturally it has a domino effect on testing. It's always testing that suffers. What can be done so that test team does not wait to do their job, testing? When we come to Agile, it becomes even more difficult, especially when you have services sitting in cloud. Testing becomes a real challenge. Code is delivered by a third party, and sometimes open source. You never know who was the owner, and sometimes pay-per-use. Think about when you run a performance test, the number of times you may end up calling that service. Are we going to pay each time we call the service? It's too expensive. Dependency in terms of response time is very important in composite applications. Once you go through the gateway, you have to synchronize the app for the third or fifth composite app. SLA cannot be more than a few seconds. If you can do the performance test from the beginning, imagine the advantage we would have. We can change the architecture or the algorithm. We can identify bottlenecks from the beginning. This is a very common diagram of the challenges the business is having, as seen in the diagram here. some of the services won't be ready. They are under development, under construction. Some of the database will not be available, or some of the services may be coming from mainframe, and you would have access at certain times of the day. Your login can be single sign-on or through mainframe, and some of the services you may end up paying for them. HP Service Virtualization provides a good solution for this type of environment. Due to the nature of these applications, testing is very important. As you can see, Service Virtualization can design, learn, and simulate the services. By virtualizing those services, we will be capable of testing no wait time. You have not heard it wrong. Test teams do not have to wait anymore. Data scenarios will be virtualized as well. These services will stop the dependency-related issues in development and test. They will always be ready for use. Development team and testing can share these services, which will lead to lower the cost for development and infrastructure. In this typical performance test environment, you need to test all these components and services. When you have limited access, performance test becomes a real challenge. I'm sure you're familiar with performance test components. You have your load generator, you have monitors, virtual users. In an application, to go from point A to point B, there may be some dependencies, as we have talked about before, service level agreements, so that the application does not fail. How would you test that? When the SLA is not met, it means some part of the application is bound to fail. You have to capture response time, throughput, and performance-related matrix in a timely manner. What will happen if you cannot get these matrix? There can be SLAs related to go from point A to C, so the application can perform in the way it's supposed to be. If the services belong to a third party, how will you test them, such as PayPal? If the services do not perform, what would you do? Well, with HP Service Virtualization, we will be able to test. Those services can be virtualized and placed in a load runner script and can be called from load runner. Both developer and tester can work on it. Both teams can develop their own services in a virtual environment, or they can share them. As you can see, when the SLAs are met, the application is good to go, and you can monitor response time, throughput, and other related matrix to your regular load runner monitors. And the developer can embed the script in load runner script, and the tester can put their services in load runner script and prepare a scenario where they can see everything in detail from the monitors and what would happen when you have a certain number of users, what would be the response time like, what will be the end results like. We can use HP Service Virtualization for mobile app testing as well. Chandra is one of our partners, and it collects information from real-world network information. You can use these matrix in load runners. And then the end user would have, we would see what the end user will have for response time and throughput, like a real-world experience. HP Service Virtualization has a full automation, especially in agile methodologies. Testing, test automation, and communication is very important. Development and test cannot wait for other apps to be ready, just like in composite apps. By virtualizing missing components of the application, there won't be any downtime for development and test teams. HP Service Virtualization supports a wide variety of protocols. By virtualizing services, we can do automated, functional, performance, and security tests. We can use UFT, load runner, and performance center. With HP Service Virtualization, we can simulate configuration, data, and performance of the services all together under one umbrella. This is a customer testimonial from TTNet. TTNet is the largest internet service provider in Turkey. They have more than 6 million customers. They are the biggest internet services providers. They were having real problems in test environment, and they were not happy with the production and the number of defects they were getting from production. They had to deploy more than 200 applications per year, and they had major delays in testing, so they were extremely unhappy. They had dependencies on third-party services. They had dependencies like development is not ready, or they had to work after hours. They had some authorization-related issues. After HP Service Virtualization, they applied Service Virtualization, and they are extremely happy right now. It really reduced test wait time 100%. So on average, they were waiting like 5 to 8 days per month. They were losing actual testing time. Now, they are not losing any time. 95% of test cases are available through use of HP Service Virtualization. They increase their test cycles and coverage 45%, and they have less defects in production. This customer is extremely happy with their achievements through Service Virtualization, and they are using those services in performance tests as well, and they have automated those services with functional testing, QTP, UFT. So they're extremely happy. Well, with Service Virtualization, we can facilitate faster tests and to prepare faster test environments for configuration and simulation. We can improve performance measurements with simulation and virtualization without stubbing. Imagine the amount of time and money we can save. It's easy to adopt, implement with the talent already you have in your existing performance teams. It integrates with load runner and performance center through controller. It enables fully automated scenarios for loading the system under test and simultaneous virtualization for test. We will have almost like a real user experience for response time and throughput when we run the performance test. In the same way, we can grow a library of suite of reusable test scripts or functions in load runner. We can also create growing library of virtualized responders. This means increased reuse across all projects. With Service Virtualization, according to VOC Snapshot report, here are some of the metrics that we collected. As you can see, it increases services availability on average 50%, which leads to faster time to market and less defects in production. With Service Virtualization, by reducing wait time, no wait time for test team, it's a reality. It will decrease software cycles 23%, shorter test cycle, and increased test coverage, as you can see, like 58 and 45%. It's a great tool that brings a lot of good solutions. Now, I would like to pass it to Mirek, who would do his demo and would explain the technical components of HP Service Virtualization. Here you are, Mirek.
Okay, so if you can pass me the presenter.
Sure. Before that, we do have another poll up on the screen. What are your current challenges for performance testing? Please select all that apply. So the votes are still coming in. Just give everybody a few more seconds here because lots of votes are still coming, I see.
It looks like people have a lot of challenges.
Yes. Okay, I'm going to close the poll here. And share the results. Bernard, what are your thoughts here?
Wow, on this one here, it looks like we have a very diverse group here of challenges. The highest challenge coming in at almost 3/4 at 73% is complex platform and composite applications. The next is almost a tie between the time on scripting and no test environment, not enough resources to test. Both of those coming in at 45 and 43% respectively. And then the lowest challenges seem to be with test data preparation. I'm sorry, that's at 49%. And correlation is at 26%. So the test data preparation, complex platforms, composite applications, no test environment, not enough resources to test seem to be all coming in at about half the audience today.
Okay, so I take it from here. So hope you see my screen. Just want to confirm.
Looks good.
Perfect. Perfect. So let me start. So my name is Mirinoti. I'm the product manager of this service virtualization product from HP. And what I'll do in the second half is explain you how the product works, what is it that you can do in it, and it will show you the use case of how service virtualization is used within our testing tool, Loader, that you might actually know and use within your work. But before we start, let's look on a few components that we have in service virtualization. So basically, we have two products for the service virtualization: Designer and the Server. Designer is the part where you are designing, creating, and sharing the virtual services. Server is the part where you are deploying those services for simulation when you want to execute either functional or large-scale performance tests. So in order to design the virtual service, you have to actually create the virtual service in a Designer. So it's a GUI tool that allows you to create in a very easy way any kind of the virtual service on virtually any kind of technology that you might see coming from the composite application towards the backend. What you see on the screen that within a few steps, you define the configuration and the technology of the service virtualization or the virtual service. You define two aspects of the simulation. As Ferhan mentioned, we are able to simulate the systems from 2 points of view. From the data point of view, it means requests are coming in, response is coming back, but also from the performance point of view, that is commonly used for the performance testing. So not only that you are able to get the response, but you can simulate how quickly the response is sent back. You have, in order to control the virtual services, you have also the service virtualization control. The virtual services in our product can live in 3 states. Either you can be in a state where you are learning the communication, and it is the most commonly way to create the virtual services for performance testing. In order to simulate, you switch it into the simulation state. But you can also leverage the third state, and that is standby. So if you would like to, as part of your testing environment with the service virtualization, start using the real environment, you just switch the virtual service into the standby, and all of the communication is actually flying through service virtualization into the real application. So how do you create the virtual service? It's very easy. Since the day one, we designed it, our tool to be very easy to use, very quick to define virtual services, very quickly to define the simulation model. So basically, what you do, you choose one of the options that is the entry point for designing of the virtual service. You choose your definition of the APIs or technologies that you would like to virtualize. You fill a few parameters, and your virtual service is created. As you've seen on the previous page, you have 2 aspects that you can define. One is the functional model that is usually created by you, for you, by the recording. But if you need to change any kind of functionality, and that is most commonly used by the functional testers or developers, you can go and change the model. The model actually contains operations of the API. It contains rules that are defining the behavior of the simulation. Basically, within the rule, you are defining what are the requests, what are the responses. You can define certain conditions on top of the simulation. And you can also define asynchronous, synchronous models. You can define Servo behavior within the simulation, and so on. So as I mentioned, one of the ways to create this functional model is by learning the communication. So all of this is actually created for you during the learning, so you basically don't have to do anything for performance testing other than run the test case on a smaller scale and then execute it on a larger scale with the simulator already preset. In order to test for various conditions, we've built in the performance model within the virtual service. So again, you have the various operations based on the technologies, but for each of the operations and the service, you can define performance parameters. You can define what is the response time, what is the hit rate threshold. When the application starts slowing down, you can define a throughput, and you can already define either as a parameters on it or in a graphical way, where you basically simulate based on the number of concurrent hits, what is the current response time, and obviously none of the system is scaling into the infinity. So you can define when the application actually stops responding, and you can measure what is the response of your composite application. In order to allow you to change those performance parameters very quickly, we also built in accelerators or throttles that help you to change the parameters across the different across all of the operations and from different points of view. You can change it if you would be changing number of CPUs, if you would be modeling network, and so on. Very important part of our tool is integration. So as you've seen on our test automation slide, we have a tight integration to all of our test automation tools. So from performance testing, we have two products, Loader and Performance Center. And all of the tools have built-in virtualization control within the toolset itself. What is the virtualization integration doing for you is basically allowing you to control what virtual environments and what data do you have configured on the backend of the composite application, and if you would like to have them in simulation state or you would like to have them in pass-through, and you can actually decide what kind of the data you currently want to have and also the performance model that you want to have provisions on the backend in a very easy way. Another part of the integration is feedback from the service virtualization back to load testing tool. So at any point of your test, you know and you see within the load testing tool what parameters, what kind of the metrics are being collected and simulated, what is the real usage of your applications as it is going from your application under test towards the third-party application, for example. So what I'll do right now is I'll show you a quick demo. It is actually video. In the sake of the time, we have to speed up the load testing. Load testing usually takes the time, so we are using the video here to showcase how the service virtualization is used with the load runner. So just to give you the idea about what the use case is about. So let's say we have our application under test that is composition of UI, and it is using some of the services on the backend. So typical diagram was Ferhan showed in one of the early slides. So we have the approval service, member account service. We have also third-party service in this. But what is our challenge in our testing environment is that we have first multiple depending systems that are being called from our application. That is about the claim processing. We have one third-party production system. We basically are not allowed to do performance testing at all, and it's very hard to replicate all of this in our lab testing environment or lab environment or testing environment. So we have a huge trouble. So even we have the load testing tool on the client side, we don't know how to actually get the responses from the backend of the system. So we can, and we will, in this demo, use HP Service Virtualization. We will virtualize all of those dependencies to the backend services. We will create the model by learning. We will run one transaction that is going to the real systems, but on a smaller scale. We will then change the SLA of one of the depending services. We basically say, now the service is responding with a slower SLA, and we will execute the test, collect the metrics, and see what is the impact of such a change in very easy way in our load testing environment within our lab, without actually having a need to do complicated provisioning and replication of those systems in our local environment. So let's see the demo. So what we have here is the tool that you probably know. It's the HP load runner. It's controller that is executing the script. We have also the UI. So first, what we will do is we create the script for the load runner just by recording this behavior of the UI. So we execute a few transactions, and we also virtualize the backend services. So we have those services already created based on the description, and we create the model just by listening to the communication as it is flying from the composite application to the backend. We execute the script, and as you usually do, you watch for the parameters, what is the scenario doing. So in this smaller scale, we see that the total response time of overall application is about 1.2 seconds, and that's the SLA that we are measuring on the client side of the application. So that would be the experience. So we let it learn for a while, and we have also ability to see right into the parameters of the service virtualization. So thanks to the direct integration, we now see what is the usage of all of those services. So some of the services are not used, some of them are heavily used, some of them have average usage. So we've created our initial baseline. We've created also the models by learning. We can see that there is quite a lot of messages flying into the simulator. Some of the services in our scenario are heavily used. And we want to do our test case. But first of all, we can go and review some of the data. So just for a curiosity, we can go and review what was the data model, what kind of the data are recorded. It's actually a repeat of very simple transactional, so we see only a few data. That's actually the benefit, but even if we see a lot of messages, we keep the unique points only. So the model for the simulation is very, very optimized on the side. We can also create a performance model based on the observed data. So let's say we want to create a model that is influencing the behavior of the backend services. Basically, response time is now 2 seconds. And let's check, it's quite a long response time from the third-party service, and we want to know what is the impact. So this is where you also see our performance model. So you have the ability to play with the parameters. You have also one of the methods that is used is recorded. So you see that we recorded 29 milliseconds. That was the time. We can very easily change the scale of overall service up and down, change the ratio, create the appropriate performance model. We can also play with the graphics and do it in a more graphical way, kind of represent the scalability of the system. What is nice that we also see all the samples of what we observe. So this is the samples that we've seen flying into the service virtualization, and that's how the performance model was created. But in our case, let's say we know what we want to test for. Let's slow down one operation, save it within our model. We have it as part of a virtual service, and within our integration, you now directly can go and configure the conditions on the backend of application. So here you have the configuration of all of those services, and you select the profile that we just created, slow by 2 seconds, and we configure it. And only what we have to do is execute the scenario again. It's the same scenario, but currently running against the simulated services. So remember, now we are simulating that one of the services is slow by 2 seconds. And we immediately see the impact. So instead of 1.2 seconds, we see that overall scenario that we load testing is actually taking 5.1 seconds. So 2 seconds is having quite a lot of impact on our overall results of performance of the application. We can also see as part of the simulation, again, parameters that are flying out. We can see what's happening in the simulator, how many messages are being simulated. We can see the basic metrics into how simulator is performing. We measure also accuracy of the simulation. If the model is simulating as it was defined, as the performance is simulating within the boundaries we've defined. So it seems like everything is green. Simulator is working perfectly. So we stop the simulation, and the last case, we obviously want to do some analysis. So that's another benefit of our integration between the service virtualization and load testing tools from HP, is that all of the metrics, all of the parameters are stored within the repository of the report, and you can actually do the correlation not only between the system as you collect them, the metrics from the system as you test, but also as the communication is flying out to the third-party system or to the systems that are in production. So that was a quick way to demonstrate what is the direct value into the load testing scenario. So if you have, and if I jump back to my presentation, so if you have such environment where you need to load test and you have a difficulty to provision backend system, you can always virtualize those backend systems. You can very easily create a model that is having all the functionality that you need to test. You can very easily change the performance. You execute the test, and you have the ability to take metrics and do your offline analysis and figure out what is the impact of the backend SLA to the performance of your application as you test it. So which concludes actually my part. So we can look to questions and answers. Q&A.
Okay, thank you very much, Mirek. We're going to be asking another poll question here. This is the final poll question coming up, which is how can service virtualization accelerate your performance testing? So based on what you've seen today, just go ahead and please fill that out. Just a few more seconds here. Okay. Up on the screen here is the poll results from the question. As we can see, the big one is that we see that we're going to get a reduced time to test. About 72% of you think that, with the close seconds of being cost savings on resources and the ease of preparation of the test environment. So that's very good. So now I'm going to be getting into the Q&A. On here, we do have a lot of questions, so if we don't get to all of your questions today, do look for a follow-up to come out, as we stated early on in the presentation. So the first set of questions here are the ones that are more the common themes that we've been getting from you all today. So the first question, I'm going to go ahead and put this to you, Farhan, is how can service virtualization be used in an agile environment, and what are the benefits?
Well, in agile environment, there is no time. There is no place for downtime. Automation and communication is the key for success of agile environments. So with service virtualization, we can place those services that are not available, that are under development, or like PayPal, you can put them as a service, virtualized service, and we can automate them. We can use UFT or load runners. So there's no downtime in terms of agile environment. You can do your test and get your results immediately. And agile is lean, so you're automating those scripts and making reuse of them for test and for development altogether. I think it has a tremendous benefit for agile environments.
Excellent. Okay, another question that we got in here is how can I use service virtualization to simulate an external application that I don't have control or even access to it? Mirik, what's the answer to that one?
Yeah, so you've seen me actually doing exactly that in my demo. I don't have a control of those backend services. They are either in production or third party. What I have though, when I go into the performance testing, I have the test scenarios that I need to load test. I have a test script. Application is already working because all the connections are created. But my trouble is that I can't load test it, right? So what I do is I execute those test scenarios, and I learn the behavior on smaller scale, and then I go and simulate it in a large load testing scenario, and the simulator is behaving like the application would be scaling. Obviously, I need to put a little bit more on a performance side. So that's for the performance testing. For the functional testing, even when you want to test against certain application, you can do exactly the same. You can execute, or you can even take the applications as you have it, and you can learn the behavior of those systems that you don't have a control of. What we also have is the ability to create the simulators even when you don't know the application on a backend. Basically, what you need to know from the architectural point of view, what is the API that you are going to call. So usually developers have a knowledge of that. So you create a virtual skeleton or service virtualization skeleton. Then you fill the virtual service with the data. You either do modeling by hand, or you have the ability to import external data from the external system, like log files, or you can have test data management export, and you can import it into the virtual service. And this way, you can very easily create the functional model as well.
Excellent. And Mirik, there's one other question that seems to be really high on the list here, is do you have any way to calculate the return on investment when leveraging service virtualization?
So we don't have the ROI calculation built in the tool yet, but we have external calculators in an Excel spreadsheet that help us to drive the ROI for our customers. So what you've seen, Ferhan was showing you, is the result of the survey that the customers were able to measure. Obviously, it was the average number. Some of the benefits are even higher than what was presented. And but every ROI actually is specific for each of the customers, because you have to put a lot of information about how is your typical development cycle, how do you test, what if you do any stubbing already and it's created by, for example, developers, how long do you spend creating and maintaining those stubs by the developers? Are you able to get it immediately, or do we have to wait? What is the typical wait time that you have to wait for such assets, and so on? And all of this is put into the calculator, and we give you the indication what is the ROI for your specific organization.
Actually, Bernard, I'm working with a couple of our clients who are using service virtualization. So they're keeping track of things like number of days they were losing because they were not able to test. So they were making comparisons, how many days they were losing without service virtualization, and after they were capable of virtualizing those services, what's the test duration like? And now they have a more predictable schedule. They're keeping track of number of test cases they're able to virtualize. For performance tests, because they are able to start from the very beginning, they are changing algorithm or architecture. They're keeping track of cost savings. And as Mirik mentioned, how much time was the developer spending to put a fake code in place and how much time they're saving by virtualizing those services instead of fake code. So there are some clients that we're working with, and we're collecting information on return on investment.
All right, that's great. And another one that seems to be a really hot topic with the questions that have come in is mobile and the mobile space. So does server virtualization work for testing mobile apps? And could you explain how that works, Mirik?
So mobile applications are very hot today, and it's a specific animal in our application space because one of the biggest challenges is that they are first running on small devices that are spread across the different kinds of the network, different kinds of platforms, and so on. So we have, from the client point of view, we have quite a nice offering, both for the functional and performance point of view. And service virtualization is also relevant for those kind of use cases. So it's not different, not much different from the usual testing of the functional and performance. It's just that the dependencies and the patterns, how the mobile applications are used, are different. What is the benefit of SV is that you can virtualize at any layer of communication flowing from the mobile application on your phone towards the server as it is serving the data for the mobile application. Usually there is a middle layer. Then behind the middle layer, usually you need to take some of the data from the legacy systems, from CRM or from some databases and so on. So if you are going to test for such applications, first, from the functional point of view, again, you are touching the production environment in most cases. So how do you test the mobile application is working end-to-end? You have to simulate some of those parts. For the load testing, what you can do, what it helps you is to simulate the various dependencies as they are between the different subsystems. Again, behind the layer that is serving the data to the mobile application. And in coordination with our client testing tool and Chandra, that is having the ability to simulate the network conditions both on the mobile network and also on a physical network between the computers, we have the full picture, and we have the ability to fully replicate end-to-end scenarios, considering all of the conditions that can happen once the user hits the certain functionality on a mobile application, as it is flowing through the layers towards the backend system in closed testing environment.
Okay, and now we got some individual questions here that have come across. Glaucia wants to know, Mirik, how much involvement from the developer and programmers is needed to create the virtualized service?
Okay, so it's a very good question. So since the day one, we've designed the tool to not target the developers, but to really address anybody that is touching the application development and testing. So the tool is very easy to use. We don't have any scripting. Rather, we focus on the data. You define what is the virtual service, what is the API. You have to have a certain knowledge about the technology you need to virtualize, but then the tool helps you to create the application, expose the API, and it's up to you if you want to create a model by just observing the real system. We have also ability to learn the API itself, so even when you know just the endpoint, you just point to the application and the data types are created for you, as well as data are created for you by learning, and then you can do various modifications on the performance aspect of such a virtual service. So it's quite easy to use from various aspects. If you need to define it by hand, we also offer a tool that gives you the view into the model of the simulator. But again, it's very easy to use because you just focus on the transactions, on the data. What is the response? What is the request? What is the response? What is the linkage between that? When are the conditions that such a response is happening? And so on. So it's very easy to use.
Excellent. Okay, and Suresh wants to know, Mirik, does it support REST services?
Yeah, so the coverage technologies are in the core of the service virtualization. And what we see at our customers is a broad range of the technologies, and we can say that it's almost going towards the history of the distributed computing. So you name the communication protocol, customers have a dependency on it, and they have a need to virtualize it. So we do simulate various technologies from the legacy world, like mainframe or MQ communication. We are also going towards the more modern protocols, so like SOAP services, HTTP communication, REST services are supported as well. So with all of the aspects of the security, JSON communication, or even serving the binary data within the REST communication. So all of it is truly supported in product.
Okay. And Farhan, Nico wants to know what kind of services can be virtualized.
Well, as Mirek mentioned, you can virtualize almost everything. But what I'm seeing most commonly is mainframe services, because there's a lot of activity going on legacy systems and modernization. So we do virtualize mainframe, REST, Litho, SOAP, all of them really. And our R&D would be happy to work depending on the situation. We do support a wide variety.
Okay,
it will be available in our website too. There would be a list of services that we can virtualize.
Okay, and a follow-up question to that, Farhan, is are the services created by the virtualization tool able to be deployed in different environments, such as dev, integration, test, and performance?
Absolutely. That's the whole purpose. You can virtualize those services. You can use it in development. Let's say, as in my slides I showed, especially in composite applications, to go from point A to C, you need missing components. Maybe they're under development or you have no access. So you can replace those missing components by virtualized services in development, which is very commonly used, by the way. I have seen it in my visit to some of our customers. And then, of course, it can be integrated for system tests, for performance tests, as Mirek had shown in his demo. The benefit is really reuse and sharing, and it brings a serious cost cutting.
Okay. And Mirek, Sadya wants to know, what is the fundamental difference between performance testing with service virtualization versus performance testing with end-to-end apps?
So the difference is that it's much quicker to do. You can have a much broader test coverage. So basically in end-to-end testing, you rely on the speed of the applications as you have them defined. With the virtualization, you can on every layer define what is the condition that potentially can risk can influence the behavior of the application from the performance point of view, and you can actually simulate and test if you have the correct mitigation mechanisms in the application itself. In the real world, end-to-end application, it's quite a lot of work to achieve such a testing.
Well, actually, I have an additional comment for what Mirek has said. As he mentioned, you know the performance of the service itself, but you can build your scenarios in load runner or performance center. Success in performance test depends on capturing the real world, how you emulate them. It's not only one service. One service may have 5 different services embedded in it. So you know the performance of each of these services. But when you combine it in the whole picture, when you have different scenarios running at the same time, that's where there's a major difference between your performance test and performance of your services and what would happen in the real world. It's a very powerful tool.
Okay, and we're running a little bit low on time here, so just a few more questions. Mirek, Jim wants to know, if does this interface with HP DSM or OMI?
Currently, we don't have the direct integration between those two products. So obviously, we are more focusing on the testing, automation, and integration within our application automation and management tools. But as we have in our strategy, we are looking also how service virtualization can be leveraged in the operational side of the house. So one example might be that you have a real application and transactions are being monitored, but there might happen some incident and some application is going down. So what you want to do is basically capture the context and the behavior of the applications as this error happens. So at a later time, developers have a very easy way to replay such a condition. So this is the potential way we want to work with the BSM and how service virtualization could add value into the operational side as well. But it's not currently not current focus of our product.
Excellent. So we got time here for one more question before our cleanup, and that question comes to us from Nico. If your service utilizes a database, how do you simulate capacity parameters from the database impacting the performance of your service? Merrick, how would you do that?
So database is the specific case. We are itself using the database behind the service virtualization. So what we are able to simulate is the behavior of the external behavior of the database interface, which is usually JDBC or ODBC. So you can specify again the high-level parameters. But if you would like to play with the pools and such a parameter, we don't have actually this kind of the simulation of the capacity in the tool. We are able to simulate the behavior. We are able to simulate the external view of the database. Either the database is fast or is slow. But the capacity planning will have to be done in a real or configuration of the database would have to be done on a real instance of the database itself. That also comes to the point where if you want to try to simulate the database, in this specific case, the simulation will always be slower than a real database because that's the nature of the database to be the fastest option available.
Okay, excellent. So that's all the time that we have today then for the questions. And Merrick, if you would please advance to the next slide here. Okay, and, oops, I'm sorry, there we go.
Okay, so if we are able to conclude, we would like to share a few contacts with everybody, all of you. If you have any questions, feel free to send questions to performancetesting@hp.com or either to myself, Mirek Novotny at hp.com, or Ferhan Kiliko at hp.com. I'm the product manager. Ferhan Kiliko is the product marketing manager. You can always get more information about the load testing solutions from HP website. Specifically for service virtualization, you can go to link hp.com/go/sv. Load testing tools are and load runner are covered on hp.com load runner.
Okay, thank you, Ferhan, Marek, and Bernard for bringing this presentation to the Vivint community today. For everybody who is here, if your question wasn't addressed, the team here will be writing up some written responses. And within, I would say, 4 or 5 days, you will receive an email with a link to a blog that answers all of your questions, as well as a link to the recording and the slide deck from today. So again, thank you, and we hope to see you at a future event.